This presentation is being recorded and you are currently in listen-only mode. Now, without any further delay, I'd like to turn today's meeting over to our presenter, Adrian Hammond. Adrian, you now have the floor.
Thank you, Jana.
You're welcome.
Well, I'm Adrian. I work for Testhouse based in London in the UK, and as Jana says, we're talking about Agile with TFS. So about Testhouse briefly, we're based in London, but we've got offices around the world, including sales offices in the United States and a number of offices elsewhere in the world. We've got a whole variety of clients, and here's a small list of some of them. And right at the moment, we've got a number of projects involving finance houses around the world and retail organizations. Today's presentation, this is basically the topics I want to cover. A brief discussion of what Scrum is, and then moving on to ALM, Application Life Management with Team Foundation Server and Visual Studio, and then go into some more details of the Scrum method and how TFS can help with those things. And finally, a definition of what done means in the context of Scrum. So Scrum is an agile project management style where the teams cooperate. We have an incremental and iterative development approach, and I think Scrum comes from the notion of once a day the team gets together and has a quick conversation about what they've done and what they're planning to do in the near future and any problems they're having. And the whole purpose of Scrum and Agile in this context is to deliver business value. The three major participants in the Scrum process, the product owner, the development team, and the Scrum Master. The owner understands the business case. He looks after the requirements, and he drives the project in the sense of what it's meant to do, and he's the main contact for anything to do with the project itself. The development team is a cross-functional group. It's a mixture of people whose skills include testing and developing and QA and so on. They're not divided into these different groups, but their team works as a collaborative whole to develop the part of the project, and they organize themselves as to how they will apportion the work between them to create that part of the product. And the Scrum is about creating a potentially shippable product during every sprint. And then there's the Scrum Master. His job or her job is to look after the team, protect the team from outside disruptions, and to keep the team focused on what they're doing, and to monitor the team so that in the future it can do things better. One of the big parts of the Scrum process is doing things better in the future, monitoring what you're doing today, ironing out any problems so that in the future you can do it better. So in the Scrum we have a daily meeting, a short meeting where everyone has three questions they answer: what they did yesterday, what they plan to do today, and what problems they've got in terms of what is preventing them from doing their work. So the team can jointly know what the whole team is doing and progress on the project. So the benefits of Scrum: it's a faster communication between the members of the team. The flat structure of the hierarchy, and it's the team that succeeds or the team as a whole that fails. It's all about getting a small group of people to work cooperatively to make good business value. And the team is able to respond fairly quickly to changes in product goals. But the challenges you get when the team moves away from the goals, when the team loses focus. The daily Scrum meetings are there to just talk about what happened yesterday, what's to be done today, and impediments. but that can turn into a discussion. So the team has to be aware of that and keep their focus precise. And then the confusion over what is happening internally and externally. So the Scrum process is very iterative. The product backlog is the list of requirements to be done. A selection of those are chosen, the ones that are important now for the next sprint. There's an iteration on over several days to process that group of requirements and create a piece of working software. Some of that will create new requirements or bugs or so on. And that goes into the operations backlog where they're monitored and become new requirements. A bug essentially is a requirement to make that bug go away. So the whole process is an iterative process. So Visual Studio provides, with Team Foundation Server, a whole range of products to help make the Scrum process, the Agile development process, work efficiently. There are multiple ways to access Team Foundation Server. Visual Studio allows you to access things and to develop software and view work to be done, reviews required, and so on. The web access is a major interface to Team Foundation Server. It allows lots of reports and views of the contents of the database. Recent enhancements to to the web access allow you to do a lot more with creating test cases and managing parts of tests that previously required the Microsoft Test Manager. You can export from Team Foundation Server into SharePoint to give status reports to a variety of people via the normal SharePoint systems. And there's a number of import-export mechanisms between Team Foundation Server and the Microsoft Office programs, including Excel and Project. Team Foundation Server is basically a database. It's got a pile of APIs to allow you to access it, and these various programs sit around and use these APIs to allow you to get at the data within Team Foundation Server and to put more data into Team Foundation Server. So you're getting all the benefits of your Agile process, and the data is managed by TFS. So the Scrum framework, we have the product backlog, which initially is generated from the high-level requirements of our project. And then we plan a sprint. We plan to make part of that backlog into a potentially deliverable software. The sprint is 2 to 4 weeks of work. Normally a project will choose a sprint duration. If the duration is much less than 2 weeks, then the overhead of creating and managing sprints becomes unreasonable compared to the time available to do the work. If the time goes much beyond 4 weeks, then the sprint gets too big and people start forgetting what they've got to do in the future and forgetting what they've done in the past and how well it worked. 2 to 4 weeks seems to have become a good period for doing the work. And we have, within the sprint, you have the daily meetings about progress and so on. And when you've got the potentially deliverable software, the output from that can be enhanced items for going back into the backlog, as in refining requirements for the future. It can also be fault reports and so on. The whole process is iterative, as shown on this screen. This is a slightly different way of looking at it, a simplified one. The backlog leads into a sprint backlog, the work to be done in a particular sprint. You have the iterations and you create a shippable increment. From the Team Foundation Server, we get a whole lot of different dashboards and screens which allows to see how the sprint is progressing. In some non-Team Foundation server environments, a lot of this work is done by having a whiteboard with yellow sticky bits of paper which you write the items on and stick them to the board and then move them around as things happen. Team Foundation server kind of mechanizes all that and allows a lot more items to be seen about how the project is progressing. So this screen shows some of the items that are available. I don't plan to discuss this or some of the other screens in detail. They're more to show you what kind of thing is available. Team Foundation server shows a whole variety of different charts of how the project is progressing. Most of these are available out of the box, so to speak. They're just provided by the system. So we can get information on how our test is just progressing, how our test plans are working, what's our builds doing, status on the work on bugs, more about the bugs. You'll notice the slider at the bottom of the screen has these areas, so we can learn about how our tests are covering our code, what portion of our code is covered by the tests. And we can also learn about the churn of code, how many lines have been added in a particular sprint or time area, how many lines have been deleted, and how many lines have been modified in a particular area, a particular sprint. We can view how the team is progressing, quantities of for each user of the team, how many bugs they've got to work on, how many code reviews they're meant to be doing, a variety of things about the progress of the individual member of the team. There's a whole pile of the whole pile of out-of-the-box reports available, I beg your pardon, with a variety of charts available to show what's happening. And out of the box, there's a whole pile of reports which are available to give different information about what the project is doing. So these are available to both the three main parties in the Scrum process, but they're also available to other members of the organization, managerial members of the organization or accountancy members, just to see how the project is progressing and how the company's valuable money is being spent and whether it's being spent wisely. So the work items within our product backlog, when we start, they tend to be high-level requirements for work to be done further down the process, and as the project progresses, those work items are refined to give more detail until they become individual tasks that are sensible to be implemented within a Scrum sprint. Some of these requirements, some of these backlog items become test cases. Some are added afresh as bugs from previous work that's been done. So the items form a hierarchical list. Within the Team Foundation server, we can see details of the current sprints and future sprints. We can even open the past sprints to get details of what happened there. Within each sprint, we have information about the resources available, the number of days, for example, of time available per person to do the work on our project. So we can just monitor the progress of the product, of the development of the sprint. In terms of what our tasks should be, we have to think about what is flexible and what is fixed. The resources available to our project, the number of people available to work on the project, that's fairly fixed. We can't often change the number of people available, so that's the least flexible part. Our customers, our end users, have an expectation of when the project will be delivered to them. Historically, many projects have slipped, so perhaps the schedule is somewhat flexible in a project. The most flexible part of the project is the scope, which can change exactly what we deliver and when in our particular sprints. So when we're planning what tasks go into which sprints, we have to think about which items fit into where on this flexibility matrix. The life cycle of a project: we create the backlog items, and then over time we refine them and give more details of them. That's generally the process of grooming the requirements to give more information on them, to specialize them to how the project is actually progressing. At some point, the requirements, when they are sufficiently detailed, are assigned to a release of the project, and then they are accepted by the development team as items to be done in a particular sprint. The team then organizes itself, the development team organizes itself to produce that particular sprint and the items in it, and hopefully all the items in that sprint are completed. Now there's then a question of what does it mean to be completed, what does it mean for a thing to be done, and I'll talk about that a bit more later. Part of getting things done is creating test cases, perhaps the current sprint or perhaps test cases for items in a future sprint, and also part of getting it done is recognizing faults which can't be cured in this sprint, faults which are maybe the low importance faults, or maybe they're faults found in work created in previous sprints. So we have to create the fault reports as required, and we have to manage impediments and manage things which stop us from doing the work properly, and that might create new backlog items. In terms of bugs, the Microsoft software, in particular Microsoft Test Manager and Visual Studio, have mechanisms for creating fault reports quite easily. From Microsoft Test Manager, you can run a test within MTM, and then if something goes wrong, click a button and most of the fields of a fault report will be filled in for you, and then you submit that and it's put into Team Foundation server, where it will be managed as any other backlog item. Of course, a good bug, a well-formed bug, has to be complete and allow the developers to understand what went wrong, and MTM with Visual Studio helps on that, because the bug can have things like IntelliTrace data attached. It will have data about the environment of the test, the particular test case that was run, the operating system and other software that was there. The belief is that these bugs are sufficiently documented to reduce in many cases the number of occasions when the developer says, can't reproduce it, it works okay on my machine, because the amount of detail provided in the fault report is good. The web access to Team Foundation server provides a lot of information. We can lay out the different sprints and see what work is to be done in them. The backlog items are basically ordered so that you have some kind of priority ordering. It's not a pure priority, it's a mix of values appropriate to the project, so it takes into account risk and timescales, and is it required sooner or is it required later. By merging all these aspects of a backlog item together, we get an order at which things should be done, and then that begins to dictate whether it should be in the current sprint or the next sprint or delayed later. And of course, items in the future sprints can have their orderings adjusted as the project progresses. And again, against each item we have an effort required to do that work, so you can gather as many items together as fit into the available effort of the team, so you balance the work out over the duration of the project, so that each sprint has a similar amount of effort to do its work. Another view of what you can see using Team Foundation Server to get details of your project. Again, there's many different displays of what happens, and for example, we can specify the availability of people to do work. In this case, Annie is offered a day off somewhere, and so her capacity is reduced. We can view the items in detail in the conventional kind of chart, of a bit similar to the way that the sticky labels are put on a blackboard, but Team Foundation Server will draw this blackboard for us, so it means that people can see what is happening and don't have to be in the room with the actual whiteboard containing the yellow papers. So Team Foundation Server will support distributed teams if that's a requirement. So we want to know what it means to be done. What does it mean for a work item, a product backlog item, to be completed? There's a lot of different understandings of done, and a number of projects have had problems because the definitions of done vary from one person to another, and one person has said this work item is done, and another person has had a different interpretation and then has been disappointed by what has been achieved. The concept of done, there's a whole variety of different items that we can consider. We can only know if something's done if we know what it actually is. So we do need a clear user story. We do need a clearly defined task. We need the approval of the product owner so that they know they've defined the product backlog item carefully. And we need to make sure the backlog items are updated to say what has been worked on them, what impediments have been achieved. We need to update the backlog items with respect to adding new fault reports if required. It can only be done if the design is completed. Have the unit tests been written? Has the code been documented? Is the code completed? Do we think there's any missing pieces of it? How many of the unit tests have been executed, and what portion of them pass? We need to think about regression testing. Done might require that all the unit tests or 90% of the unit tests pass. We need to think about the quantity of code that's executed by our unit tests. Some teams require 80 or 90% coverage of the code within the unit testing. Team Foundation Server and Visual Studio, of course, can monitor code coverage and give you those statistics. Adding new code into a project, we could just add new code and not go back over the old stuff, but a good project merges the code in nicely and refactors existing code to allow for new code coming in, so the code is beneficial to the organization, so it doesn't become a liability, so that people in the future can understand what is happening without having to visit many copies of much the same code. So we need to make sure that our refactoring is done correctly. The code is only done if it's been properly checked into our version control system. Again, that can be TFS. And we need to make sure the code has been merged onto the correct branches of our version control system. We can think about the code reviews, both automated with things like ReSharpener and also reviewed by our peers. And has all the testing been completed at the different levels? So done has many possible meanings. So that's the end of what I really wanted to talk about with the Agile and Team Foundation Server. A little bit more about Testhouse. We've got a number of resources available for you to view different aspects of what Testhouse has done. We've produced a number of other webinars which are available via YouTube and also more directly via these links on this page. And we try and keep up-to-date status of what we're doing via our Twitter account. So please have a look at some of these things. So I say thank you very much for listening to our presentation. I hope you found it useful. And if there's any questions, please do email me about technical issues, or my colleague Tony if there's any particular questions about Testhouse. So thank you very much.
Thank you, Adrian. Now I'm going to request control so that you'll soon see 4 quick poll questions in the slide area. I'll scroll through them for a few minutes after the meeting to give you a chance to answer. And if you have further questions for Adrian, feel free to put those in the IM window and he'll stay on the line for a few minutes. Your feedback is valuable to us, so please take a moment to answer these poll questions prior to logging out. And as a reminder, you can request a copy of the slides directly from our presenter today or in the IM window and make a request to him via his email address at Testhouse. And maybe, Adrian, if you want to put your email address in the IM window, that might be helpful. I'd like to thank Microsoft partner Testhouse and speaker Adrian Hammond for their presentation today. Testhouse presents Using the Agile Framework in TFS 2012. And with that, ladies and gentlemen, this concludes today's online meeting. Thank you for joining us, and once you finish the poll, you may now disconnect. Thanks.